Ok, la teoría molecular tiene 3 reglas. La primera regla es que las atomic orbitals, que son la s, la d y la p orbital, ¿verdad? Tienen que ser la misma cantidad que las molecular orbitals. Entonces, tú tienes una s orbital de la hydrogen y tienes otro hydrogen y tienes 2 s orbitals. Eso quiere decir que en el medio el modelo va a tener 2 orbitals. Esa es la primera regla. Entonces, ¿qué pasa? El modelo debe verse de la siguiente manera. A ver si se puede ver. Maybe ahí se ve mejor. I don't know if déjame hacerlo con marcador, espera. El punto es que tiene la misma cantidad de orbitals que entran o que tienes atómicas, que son por ejemplo la S, D y P, es la misma cantidad de las moléculas de las molecular orbitals. Entonces se ve así. Es una S y esta es otra S. Si tienes una S, one S de hydrogen y tienes una one S de hydrogen, tienes que tener 2 S orbitals. Tienes una S de un lado y una S del otro, son estas 2. Entonces, ¿qué pasa? La regla es la siguiente. Tienes la misma cantidad, tenemos la misma cantidad. Vamos a poner que tenemos 2 S orbitals, una arriba y una abajo. Ahora, otra regla dice que hay una de las orbitals que son anti-bonding y una que es bonding. La anti-bonding quiere decir que es inestable cuando los electrones están ahí. Y la bonding es la que normalmente tú pones los electrones primero. Entonces, ¿qué pasa? No sé si te acuerdas que la S es un sigma bond. La P tiene 2 pi y un sigma. ¿Por qué? Recuerda que la S agarra nada más 2 electrones. Eso es una sola línea. Tú pones una sola línea y pones 2 electrones. Pero cuando tienes la P, recuerda que la P puede agarrar, según la probabilidad, como 6. Si no me equivoco, déjame ver. 1, 2, 3, 4, 5. Ok, puede agarrar 6. Eso quiere decir que tienes 3 espacios. Si tienes P, tienes 3 espacios. Puedes agarrar 6 electrones. ¿Ok? So, la S es una p orbital. Sigma, perdón. Una sigma. Un sigma bond. Y la P tiene 2 pi y un sigma. ¿Ok? So, lo que vamos a hacer ahora es tratar de agrupar esos pensamientos. Primera regla, necesitas la misma cantidad de orbitals. Si tú tienes una S y una P, al final tienes que tener una S y una P. La segunda es entender que la S orbital tiene solamente un sigma bond y la P orbital tiene 2 pi y un sigma. ¿Por qué? Porque la S nada más agarra 2 electrones y la P agarra 6 electrones. 2 en cada uno de los bonds. Ahora, después que entiendes los bonds y que necesitas la misma cantidad, ¿cómo tú pones eso en un diagrama? Lo primero es que tú no vas a poner los diferentes niveles de órbitos juntos. Eso quiere decir que si tú estás poniendo el nivel de 1s en un diagrama, tú no vas a poner el 1s y el 1 y el 2p. El diagrama es simplemente, por ejemplo, de la p orbital o de la s orbital o del 2s orbital. Es de esa parte específico. So, si yo te digo a ti que vamos a hacer el diagrama de hydrogen, que es más o menos esto, tú colocas, uno va a ser tu bonding y uno va a ser el anti-bonding. Recuerda que hydrogen tiene 2 s orbitals, en este caso 2 hydrogen tienen 2 s orbitals y una de ellas va a ser un anti-bonding. Y recordamos que la s orbital tiene un sigma bond. Sigma. Entonces, los dos tienen un sigma bond y una de ellas es antibonding. ¿Qué es lo que tienes que comenzar a hacer? Agarra el número de electrones, por ejemplo, hydrogen tiene cada uno, y vas a comenzar a llenarlo por la bonding, the bonding orbital. Pones uno para abajo y uno para arriba, y te va a quedar así. Ahora, si tú tienes helium, por ejemplo, tienes helium, ¿y cuál es helium? Helium es 1s2. Eso quiere decir que tiene un s orbital con 2 electrones cada uno. En el caso de helium, tú vas a tener la misma cosa. Vas a tener 2 sigma bonds because the s orbitals always have sigma. It's just 1 sigma. That's a rule. An s orbitals only have 1 sigma. Okay, so you have the sigma, and then you have the bonding and the anti-bonding. This way. It doesn't matter where you place it. It doesn't matter. Normally they place it up. So, in helium, you have 4 electrons. You have 2 for each helium. So, and each of the orbitals are going to hold 2 electrons. So, for example, the sigma orbital holds 2 electrons. So, you're going to put the first 2 electrons and then the other 2. Because in helium you have 4. So, you start putting the electrons here, 1, 2, and then 3, 4. First, you complete the orbital, the bonding orbital, and if you need more space, you go to the anti-bonding, which means that this element is unstable. When it's unstable like this, it means that it doesn't come as a diatomic molecule. So that's something that you learn from the molecular theory. If you have something like this, you are likely to have it a diatomic, meaning that the 2 molecules together are stable. If you have the 2 atoms together and are unstable, it means that you cannot have, or it's really rare to have the atom as a diatomic molecule. So now we're gonna go to the p orbital. So let's say that we're gonna do something like carbon. Carbon, the configuration of carbon is 1s2, 2s2, 2p2. Okay? So as I told you before, you're going to include all the orbitals in the molecular theory model or diagram. You only pick one. Let's say the p orbitals, the 2 p orbitals, or the 2s orbitals, or the 1s orbital. So in this case, let's do the p orbital. So in this case, you're putting 1 carbon and 1 carbon. And you know that the p orbitals for carbon are 2p2, right? 2p2. So now what you're going to do is you're going to see how many bonds we have in a pi, una p orbital. And the p orbital we have 3, because we have 3 lines, because we have 6 electrons. For example, if you're talking about a d orbital that has 10 electrons, you know you're going to have 5 of those. Because in this case, p has 3. It holds up to 6 electrons. So, the rule says all the p orbitals have 1 sigma 2 pi. 1 sigma 2 pi. So, we put 3 together here. 1 sigma 2 pi, 1 sigma 2 pi. Okay? So, this is the p orbital. Remember, p orbital are the 3 bonds. Each of them can hold 2 electrons. So, you have, for this carbon, you have, let's say, this orbitals, and for this carbon, you have this orbitals. However, in carbon, you have p orbitals, but the p orbitals only have 2 electrons each. So how do you know where to put the electrons? Well, the first thing you need to know is just to label which one are sigma and which one are pi. So remember, you have 1 sigma and 2 pi. And from the sigma and from the pi, you're going to have 2 sigma and 1 pi that are anti-bonding, and 2 pi, pardon, and 1 sigma that are bonding. So that's what the little stars on top means. So we did this one's the anti-bonding, and we did this one's as the bondings. So la siguiente rule of molecular theory says that if you have enough space, which is the case, you only have 4 electrons in total, 2 per each carbon, and you have a space for 6 electrons. So they're telling you you're gonna put it in the order of the highest energy. So quiere decir eso, que you're gonna put the electrons first in the pi bond. You fill the pi bonds and then you go to the sigma. So if you have here, this is the carbon, this is the anti-bonding. We don't go to the anti-bonding before we go to the bonding. Okay, so you have 2 electrons and they're telling you have to fill first the highest energy. The highest energy is always the pi. The pi has more energy than the sigma bond. In the case of the s orbital, you only have sigma. It's not a problem. But in this case, in the p orbital, you have 2 pi and 1 sigma. So start from the pi. You have 4 electrons. It means that you're going to put 4 electrons in the pi bond. And the sigma is going to be empty. And the anti-bondings are going to be empty as well. So let's pick something that has more electrons. But they are in the pi, for example, region. Let's say fluorine. The configuration for fluorine is 2p, well, it's 1s2, 2s2, 2p, 1, 2, 3, 4, 5, 2p5. So again, having a p orbital, we are doing the molecular diagram for the p orbital. So having the p orbital, and it doesn't make much sense to make the diagram of the s orbitals in this case. Remember that the ones that we care are the ones on the outside. That's why we do that one. So let's F. We have a p orbital, so it's the same thing as with carbon. You start doing your diagram, putting the 3 bonds. 2 of them are pi, and 1 of them is sigma. And from the group, you're going to have half of it, let's say, the 2 pi and 1 sigma that are antibonding. Okay, so this is fluorine. This is only the labeling. So now how you're going to start? You have, in the case of fluorine, you have 5 electrons, right? So you start from one of the orbitals. 1 pi, 2 pi. So in this case, you fulfill all the pi orbitals. So you go to the sigma orbital. In the case that you have, let's say, more, if you have the next element, I think is neon. Yeah, neon is going to have a perfect configuration. It means that it will have the pi orbitals are going to be full, but the sigma orbital is going to be full as well. Okay, so this is the first part of the video. Watch it, and if you have any questions, let me know.